In this lesson, you will learn how to find the mean and standard deviation of a binomial random variable. Recall that to find the mean of a discrete random variable, you multiply, add. That doesn't change just because the situation is binomial. What also doesn't change is the terminology. I could ask you for mu of x, or the expected value, e of x. Whichever way I ask, I'm looking for the mean. Let's try an example. In example number 1, let x be the number of tests a student passes. The probability of passing any given test is 0.7. Assuming that each test is independent, what is the expected number of tests a student will pass if he takes 5 tests? I've said it before. Whenever you see expected number, I want bells to go off in your head that say mean, mean, mean. Expected should always translate to mean in your head. So all I'm asking you to do here is to find the mean of x. One way to do this is to write out the probability distribution. You can use your calculator to find all these probabilities and then multiply, and add to get the mean of x. If you have a distribution that's rather large, you don't want to have to write out every term, but make sure that whoever may be checking your work can tell that you know what you're doing. So in this case, you could say 0 times 0.0024 plus 1 times 0.0284 plus ... plus the last one, 5 times 0.16807. So feel free to ... it if you want to. When you do the math, you get approximately 3.5. So the expected number of tests that a student will pass out of 5 is 3.5. You also have a formula for this. Looking back at the formulas related to binomial distribution, we know the first one is just the formula for calculating probability of our random variable equaling a specific value. The one in the middle, mu of x, is the mean or expected value of x. It says that the mean of x equals n times p. And the standard deviation for x equals the square root of n times p times the quantity 1 minus p. The key thing here is that these formulas only apply to binomial distributions. You can't just use the formula to find the mean of any discrete random variable. It has to adhere to those 4 conditions in a binomial setting. So let's look at the formulas one more time. For a random variable x that follows a binomial distribution, where n is the number of trials and p is the probability of success, the mean of x is just n times p. And the standard deviation of x is the square root of n times p times the quantity 1 minus p. Let's look at this in action. My answer was 3.5. I did this by making a probability distribution chart and multiply, add. But because this is a binomial situation, I could use the formula. The formula says just take n, which in this case is 5, and multiply it by the probability of a success, which is 0.7. So n times p, or 5 times 0.7, just equals 3.5. It does save us quite a bit of work, but remember, it only works for binomial situations. Let's practice more with example number 2. Let x represent the number of days it rains. Assume the probability of rain on any given independent day is 0.4. In the next 7 days, find the mean and standard deviation for x. Pause the video to try this on your own. Press play when you're ready to resume. Here's example number 2's solution. The key elements I need to use the formula are n and p. The number of days I'm looking at is 7, and P, the probability of rain, is 0.4. To find the mean of x, use mu of x equals n times P. That would be 7 times 0.4, which gives us 2.8. So I would expect it to rain 2.8 days out of the next 7. To find the standard deviation, I'll substitute an n and p into the formula to get the square root of 7 times 0.4 times 0.6, which is approximately 1.296. Now here's another one you can try on your own. In example number 3, let y represent the number of hits Los Angeles Angels of Anaheim player Mike Trout gets in one game where he gets 4 at-bats or 4 trials. The probability of Mike Trout getting a hit on any given at-bat is 0.315. That was his batting average in the middle of the 2015 season. Based on the information provided, answer the following questions. For A, how many hits is Mike Trout expected to get in a game where he gets 4 at-bats? For B, what is the probability that the number of hits he gets is within 1 standard deviation of his mean? Pause the video to work on this. Press play when you're ready to continue. Here's example 3's solution. The key elements are our n and our p. N in this case is the number of at-bats, which is 4. P is the probability of success, or the probability of him getting a hit, which is 0.315. Remember, expected equals mean. So I'll find the mean, which is 4 times 0.315, which is 1.26. And I can apply this formula because the situation is binomial. In part B, I'm asking you what's the probability that he's within 1 standard deviation of his mean. So it stands to reason that we should find the standard deviation first. Let's do that using the formula. That would be the square root of 4 times 0.315 times 0.685, which is approximately 0.929. So to be within 1 standard deviation of the mean, he has to hit 1.26 plus or minus 0.929. Now, where I got those numbers is I took the mean, which is 1.26, and added 1 standard deviation, and I subtracted 1 standard deviation. Because if he's within that range, that means he's within 1 standard deviation of the mean. In other words, he must hit between 0.331 and 2.189 hits to be within 1 standard deviation of his mean. But can he get 1.2 hits or 2.05 hits? No, he can only get 0, 1, 2, 3, or 4 hits in this game. So looking at my range, 0.331 to 2.189, which one of those possibilities falls within that range? Well, there are only 2, 1 or 2. So even though I'm asking you what's the probability he gets within 1 standard deviation of the mean, I'm really asking you what's the probability that he gets 1 or 2 hits. I can use the binomial distribution to answer this question. Using the formula, the probability that y equals 1 or 2 would be 4 choose 1 times 0.315 to the first times 0.685 to the third, plus the probability of 2 hits, which would be 4 choose 2 times 0.315 squared times 0.685 squared. If I do a little fancy math on my calculator, I get about 0.6843. So the probability that Mike Trout hits within 1 standard deviation within his mean is about 0.6843. Now let's test what you've learned so far with a check for understanding. We are using the same soccer team problem used in other lessons, but this time asking a different question. Here it is again. A soccer team plays a total of 6 games in a particular tournament. Assume that each game is independent and the probability of winning any game is 0.65. Let Z represent the number of games won by the soccer team. What is the mean and standard deviation of Z? Pause the video to work on this. Click play when you're ready to move on. Here's the solution to this check for understanding. Because this is a binomial situation, I can use those 2 formulas that we discussed earlier. So the mean of Z would be 3.9, and the standard deviation of Z would be 1.17. Now, if you made a probability distribution chart and you multiply, add to get the mean, awesome. That should give you the same answer. But remember, since it's binomial, I can use those handy-dandy formulas. Now it's time for the wrap-up. After this lesson, you should be able to find the mean of a binomial random variable and find the standard deviation of a binomial random variable. That concludes this lesson on mean and standard deviation of a binomial distribution. Remember, you can review this video as many times as needed for better understanding. Thanks for watching.